So hello everybody. Today we're going to make 3 proofs happen real quick, okay? You have to know these for your test tomorrow, so we're going to go over them. The first step you want to do to get this proof is we're going to prove that E equals G, so make sure that you know what you're proving, okay? And then look at the information you have. This is pretty much the only diagram we have. So E stands for this angle up here, and G stands for the angle down here. So we're going to use the fact that E plus F equals 180 because they form a linear pair. Alright, and yes, I'm doing this, even though we did this in class like 100 times. I'm still worried you're not going to get it. So, we also know that G plus F equals 180. And what we did is we had to make a relationship between E and G at the end, right? So what we did is we made 2 equations that are both equal to the same thing, okay? And the reason they're both equal to the same thing is because they're both linear pairs. Alright, now we didn't just choose any equations just to choose them, okay? We chose these equations because they were going to be particularly useful. In this case, we see that they both have F, so we need something that can eliminate. If I use EF and HG, I can't eliminate anything. There's nothing the same on both sides of the equation. So, as we apply the transitive property, and we see that since these equations are both equal to 180, they must be equal to themselves. They must be equal to each other. So we see that E plus F has to equal G plus F. And now, by the subtraction property, okay, we can subtract F from both sides, because it's on both sides, and we will receive the equation E equals G, and we will be done with our proof. We have done this so many times in class, I really lost count, okay? I'm sure we're up to 7 or 8 or something. Go ahead, now you guys can watch this video 1,000 times until you get it. I hope it makes sense eventually if it hasn't so far, okay? And there's other videos on the vertical angle theorem that probably focus on it a little more, so if you're still having trouble, watch those videos, okay? Go search YouTube and find some more information about the vertical angle theorem, okay? We have 2 theorems left, okay? We're going to prove what I call the triple line segment addition theorem because we have 3 line segments, and we're going to show that if you add up the 3 line segments that are all made up of collinear points, that we are going to get the sum of all of them, okay? So if I add up AB plus BC plus CD, I'm going to get AD, the whole line. So, yeah, adding up the pieces of a line makes the whole line. It's pretty obvious, okay? But still, we have to be technically consistent and make our proof. So, we're going to use the fact that AB plus BC equals AC, okay? And the reason this is true is because of a postulate called the line segment addition postulate, okay? And don't forget that postulates are supposed to be obvious. So if a postulate doesn't seem obvious, that probably means you haven't had enough experience with that to make it seem obvious, okay? So like on the first day of school, I was asking you guys if we had a line and this was 3 and this is 7, assuming this is a straight line, alright, what's the distance from here to here? It has to be 10 because 3 plus 7 is 10. So we already kind of get that idea, okay? If I asked you on the first day, you would tell me, yeah, this line is 10, 7 plus 3. Well, this is really because it's obvious that if you add the 2 pieces of a line segment, like AB plus BC, we get the whole line segment, okay? That's all we're using, so it's not so complicated, okay? The next step is going to be to use AC, that segment that we just talked about how it was made of 2 segments, and we're going to add that with the last segment CD. And we're going to show that that has to equal the entire segment AD. And again, that's because of the line segment addition postulate. Okay? And all of this works because those points are collinear. Since they're all on the same line, we know this has to be true. So, the last step, okay, is going to be, that's the shorter way. So let's use substitution. Okay? We see that AC equals AB plus BC. And the whole point of substitution is algebra is if 2 things are equal, then you can replace them without changing it. So, look at it this way, okay? We know that AC plus CD equals AD, okay? But I don't want to write AC. I'm going to use substitution. And so instead of writing AC, I'm going to write AB plus BC, the thing that's equal to AC, right? So here we go. AB plus BC plus CD equals AD. And we see that this is the statement we were trying to prove. Okay, we were trying to prove that AB plus BC plus CD equals AD. And we did it in 3 steps. That's the end of the proof. Sorry for hitting the camera. All right, here we go. One of the last proofs. So here's another 3-step proof, okay? Let's look at these arrows and notice the fact that these arrows mean that these 2 lines are parallel, okay? AB is parallel to CD. And I also wrote it over here to the side. If AB is parallel to CD, then A equals C. And that's the theorem we're trying to prove right now. It's only 3 steps, okay? The first step is to show that A equals B. And let's try to remember why A equals B. From our previous videos, you should remember that parallel lines have equal corresponding angles. And if I look down here at A is on the top right. And if I move up here, B is also on the top right, okay? They're not in the same position, but they're in the same relative position. Up, down here, top right, up here, top right, okay? And the reason that's true is by corresponding angle postulate. Basically, we said that it was obvious that if the corresponding angles of parallel lines aren't equal, those lines can't be parallel because there's an obvious discrepancy in the direction the lines are moving, okay? So now we need to notice something about vertical angles. We need to notice why B equals C, okay? And hopefully you remember B equals C because they're vertical angles. These angles are opposite from each other and they have a little X shape. So every time you see this X shape and you see the 2 angles opposite each other, just go ahead and mark them equal, okay? We just proved the vertical angle theorem over here, okay? We just proved it. So it doesn't have to be only up and down. It could be left and right too. All right, they have to be equal. So here we go. B equals C. And like we said, this is true by the vertical angle theorem. All right, vertical angles are always equal. All right. Well, we could do it 2 ways. We could do substitution, and we could substitute because we have to prove that A equals C. Okay. So if we do substitution, I could substitute in A for B, and we get the fact that A equals C, okay? I use substitution. You could also use transitive property, and it really works the same way. If A equals B and B equals C, then A equals C. That's the definition of the transitive property. So you can look at transitive property as being a special case of substitution. It's up to you, okay? So there we go. This is the last proof. I hope you guys have had plenty of practice tonight. Okay, please review every homework you've done. This is the part where I said I would upload the answer key. Okay, so please relax for a second, and I'm going to show you the answer key. Just let me make sure this is the right one. And there we go. All right, this is the right answer key. Okay, actually.